for joining me. So right here, we have a severe risk for hail tomorrow. Right here, there's going to be a marginal risk for hail in this area here. Right in that area, there's going to be a marginal risk for hail. However, it is outside of the marginal risk for wind. Bingo. Right in this area, you have an overlap for damaging wind, for hail risk. Bingo. So you see how far east the hail risk goes? But the enhanced tornado risk only goes as far east as here. So yeah, some areas actually, once again, have an enhanced risk for hail. Area right here, I'm going to highlight it actually. Right in this little region right here, this little sliver of region right here, you have an enhanced risk for hail right in this little area. Here's your hail risk. I know. That's basically your enhanced hail area right there where I just circled. Yep. Because look at your tornado potential. Yeah, because, yeah, so this is basically where your hail risk is. So your hail risk is pretty much here. This is pretty much where your hail risk is going to be, your enhanced hail risk for tomorrow. But we got something going on right now that's really life-threatening. South of Santa Ana. Yeah, for hail, we got basically a severe thunderstorm emergency for hail. See severe weather statement? Basically a severe thunderstorm emergency for hail. Yeah. Hail the size of baseballs. Let's see if there's been any storm reports, though. Doesn't look like there's been any. Okay, there's been some hail reports. A half-inch hail, okay, nothing too crazy. I'm going to go to Spotter Network right now. See if we got any reports. Let's check current activity. Okay, we got a couple hail reports. None. Not even mentioning the size. These storm reports. Let's see what the biggest hail was today. 2.75. It's basically okay. Baseballs. So a lot of baseballs today. So no grapefruits yet. Okay. Oh, we got a 3-inch hail report. Okay. Tornado reports. No tornado reports. Not a single one. 0 tornado reports. So yeah, that tornado warning that was issued, it was a spotter public reported tornado was actually a report of a funnel cloud. National Weather Service overreacted and said it was a confirmed tornado. There was actually no tornado today. All those black dots you're seeing are all hail reports. And that little triangle, that's a wind report. Okay, let's see. And that was the Porter, Texas wind report. 86 miles an hour. Yeah, that's strong. Really strong. That's really strong. Oh, we had a couple tornadoes yesterday. And a very strong wind report. And one large hail report. See, that triangle means bigger than a baseball. It's about baseball-sized hail. Yep, 2 inches. Greater than 2 inches in diameter. Had 2-inch hail report. All right, let's look at weather. Look at weather.cod. See if anything is going to be happening the next, say, week. Severe weather. There's a severe weather event we're having. Oklahoma City's under the gun tomorrow, especially North Oklahoma City. Areas around Ada should be fine. Could be some wet snow, potentially Saturday afternoon. Some convective, there might be some wet snow in the higher elevations, Western Mass, on Saturday. Well, next Saturday, yeah. Well, looks like the models are not hinting on it, which is a little surprising considering the freezing level is going to be really low on Saturday. Because the other models were showing snow. Yeah, there could be some wet snow Saturday afternoon. Yep, look at that. Bingo, there could be some wet snow Saturday afternoon. Look at that, 30s. Maybe the Worcester Hills will get a few wet snowflakes. Nothing to write home about. Just, ooh, that's some pretty cold temperatures. Hour 159 over Nova Scotia. Is that going to do anything? Yep, look at that. Snow, Nova Scotia. Let's check the Euro. See if they're showing anything. Yeah. You want to know why this is happening? I'm going to give you 2 guesses why this is happening. Starts with global, ends with warming. Yeah, global warming. I don't like using the term climate change because climate change refers to natural climate, whereas anthropogenic climate change I call global warming because that's what it is. Humans are warming the planet. That's what it is. That's what we've been doing for the past 150 years. Clearly, there's been a upward trend in temperature ever since humans started polluting the earth. But it's not an even warming. You're not having the whole planet warm up by X amount of degrees. You're having one area warm up by X amount of degrees, another area warming up by Y amount of degrees. And so what does that cause? You have instability in the jet stream because air temperatures are becoming, because the differential between the Arctic and the tropics is getting smaller because one area, the Arctic, is warming faster than the tropics, so the temperature differential between the tropics and the Arctic is getting smaller. What does that happen? What happens when you get a smaller temperature differential? You get the jet stream buckling. You get blocking patterns. These blocking patterns cause nor'easters. These blocking patterns lead to more frequent storms, more frequent heat waves, more frequent cold spells. Faster hitting too. You get these persistent troughs or persistent ridges. That's why we can't get out of our cold spell right now. Also, we're dealing with a La Nina, which favors a blocking pattern. Yes. Also leads to lower than normal ice coverage. Arctic is warming faster than normal, will lead to a lower percentage of Arctic ice. Strong polar vortex usually supports more ice building in the Arctic, which is good. Right now, there's a trend for a positive AO. That's what we want to see. We want to see a positive AO. Positive AO means that the cold air is being locked up in the Arctic. If you get a negative AO, that means the polar vortex is breaking up, and that means the cold air will spill into the country. Is Tonga Tonga responsible for why it's been colder than normal? No, it's not. Tonga Tonga, while it was very powerful, the highest eruption plume ever recorded in modern satellite history, even more higher than Pinatubo, the explosive phase of the eruption, the Plinian phase, only lasted for 45 minutes and erupted under a cubic kilometer of magma. What you had was a very large release of magma, however, not a lot of sulfur. The magma type was andesite, was basaltic andesite to andesite. Those type of that type of magma is not very explosive. Not very explosive, and would not normally erupt that violently. As I was saying, Anyway, let's look at the Arctic right now. Actually, basaltic andesite normally does not erupt very violently. Basaltic andesite and andesite erupts more like what you have at Soufriere Hills, the volcano on St. Vincent and the Grenadines. You had an explosive eruption, you had a big buildup of gases, led to a Plinian eruption that dropped pumice all over St. Lucia, especially the northern part, even down to the south coast. Eruption, there was some stratospheric injection, but the plume basically topped out around 60 to 70,000 feet. What happened at Hunga Tonga is different. Geology Hub described it as a new type of eruption called a Hawaiian eruption. Hawaiian eruptions are basically when a volcano collapses, you get an edifice collapse, you get a lot of seawater going down into the conduit, the magma conduit, very high temperatures of the conduit and the magma interact. You don't get an immediate explosive eruption. What happens is magma conduit solidifies because of the water. So magma solidifies, turns into basically solid plug. But you're still getting all that magma trying to escape out of the conduit. Now you're getting increase of volcanic gases and also a huge influx of seawater. So you're getting a lot of steam now. You're getting volcanic gases building up and steam building up. So what happens? You get a hyper phreatomagmatic eruption. No, not Surtsian or ultra Surtsian. No. You get a new type of eruption that's never been seen before, or has it never been seen before? Have you ever heard of Krakatoa and the Minoan eruption? Those eruptions may have something in common with what happened at Hunga Tonga. You had dacite at Krakatoa. Dacite, rhyolite, and rhyodacite erupts extremely explosively. Super eruption, volcanic explosivity, actually. You can get VI7 eruptions, like what happened in 535 AD. That caused the climatic changes of 535 to 550. So the 535 eruption may have been Icelandic, the 540 eruption may have been Krakatoa. But it's the one you find in the southern hemisphere. You need to line them up. Look at the sulfur spikes. If the southern hemisphere has a 540 spike and the northern hemisphere has a 2, then you know that's Krakatoa. Because, it was believed that Krakatoa erupted in 535 AD. Around 535, they talked about a haze that spread through most of the northern hemisphere. Wasn't recorded in the southern hemisphere. Well, in the southern hemisphere, there was cooling in 540s, around 540, 541 AD. So it's very likely that Krakatoa erupted in 540 AD. But now let's look at the weather again. Let's look at the globe. Let's talk about volcanic activity, because we should be talking about severe weather right now. So let's look at surface temperatures. There. Okay, very cold. Typical of a developing strengthening polar vortex. And then as spring comes into full swing and you go into middle May, the cold air should be breaking up. There we go. That should be happening. That's normal. But what's not normal is this big ridge that's developing north of Alaska, around the Bering Sea area. That's going to really hurt Arctic sea ice. But look at the 5100 line, those heights. Look at those heights right there. That is a little impressive. That's a lot of Arctic air. It's going to actually help the sea ice a little bit. And then, boom. Going to get a little storm, could break it up, and then, boom, it's going to get cold again, and then the 5100 dissipates. Oh, look. It might be, if this actually happens, that looks like a breakup of the polar vortex. Look at that. Right there, boom. Polar vortex, see that? Boom, breaks up. It becomes this cold core system trying to bring some cold air into the United States. But of course, Oh, look at that cutoff low just south of Alaska. See that system right there? Becomes a cutoff low around 258. See how the jet stream is buckling? It's not stable. That's because of the temperature differential between the Arctic and the subtropics weakening. Oh, the Arctic and the tropics weakening. Look at that, another cutoff low, hour 180. Look at that, bingo. Cutoff low right there. Could actually become a subtropical system, potentially. A lot actually have some subtropical storms that formed in the past. Wow. Wow. Wow, that's May 17th. Of course, that's how you get hail in the summer. If you ever get one of those cutoff lows in August, you get cool day, high sun angle, get a lot of instability, get hail. Small hail. Rare cases could be golf ball size, like what happened on May 31st, or June 30th, it was end of June of 2020. It's really impressive, actually. Now look at another cutoff low. Bingo, right there. See that? Look at that. First week of May. May 12th, actually. Wow. It is the first week of May right now. Oh, my goodness. Potential for hail, maybe. Anyway, let's look at the National Snow Ice Data Center right now. Sea ice is still dropping. Really hope we're going to go above that red line, though. It's going to be good if we could. Let's look at the last 5 years. 2021, 20, 19, 18, 17. We've actually been doing better this year than all the other previous 5 years, which is actually a first. Because last year we were doing pretty bad. Let's look at 16. Wow, we're doing better than 16. Hopefully this can continue. 2015. Okay, we're doing about the same level as 2015. 2014. Okay, about 2014 level. 2013. Okay, we're not doing as well as 2013. The thing is, yeah, we had a small improvement over the last few years. But the thing is, that's what sea ice does. It does a lot of huge decreases, a small increase, and it decreases again. Overall, sea ice has still been decreasing. Of course, this year it's good right now. But we all know what happened in 2012. Look at 2012. How, it was better. Let's look at 2013. For example, about the same, but then 2021 was actually a pretty good year. Yeah, it actually was a pretty good year for sea ice. And I actually was really happy about that. This actually has to do a lot with La Nina and also has to do with low solar activity, in my opinion. But overall, global temperatures have been increasing very quickly. We're still increasing. And Antarctic ice, how about I'm not happy with what it's been doing? Yeah. We hit a new record low with Antarctic sea ice. See that red dot? Record minimum. We've went below that record now with Antarctic sea ice. At least now we're above, but yeah. We haven't been doing good. Now let's go back to that severe thunderstorm I was supposed to be watching, and oh, look at that. It's gusting out. Yep. Any hail reports? Nope. No hail reports. But it's about to enter a town called Goldthwaite. Gulf both sides hail and 60-mile-an-hour wind gusts. That's about right. At least the hail isn't as big anymore. I think the only severe thunderstorm warning right now. Yeah, we've really decreased. I think this may be the last severe storm of the day. And there's one warning in Colorado, but that's not really a very impressive storm. Yeah. Texas storm is basically most severe storm in the whole country right now. Perhaps even the whole world. Yep. Australia is dealing with winter right now, or fall. So if you're going to have any storms, you're probably going to be to your north. Yep. Storm should be moving in from the... There you go. You have a high pressure system moving in. Yep. You can actually see the anticyclone right here. Look at that. You can actually see the flow of the anticyclone. Yeah, of course, it's moving clockwise. But counterclockwise, but in the southern hemisphere, anticyclonic systems rotate counterclockwise, while cyclonic systems actually rotate clockwise. Just fun fact. Northern hemisphere storm systems are counterclockwise, while in the southern hemisphere, anticyclones are counterclockwise. So yeah, fun fact. It's an anticyclone, it's a high pressure system. And of course, it's noon there for them right now. Let's look west. See if anything's developing there, So you're basically getting equivalent of a southwest wind. So where would that storm be? Where is that storm? There should be a low somewhere. Okay. Maybe it's here? Or somewhere to the south? Nope. Looks like it's... There we go. Cold front came in through here. That's a cold front coming through here. No severe weather with this system. Coming through very quietly. Yeah, pretty impressed actually. Probably going to be having storms on the north part because, they're dealing with La Nina right now, with La Nina, which for them means a lot of rain. And yep, there's your intertropical convergence zone storms, ITCZ. All right. Here, trade wind thunderstorms. AWIS. Surprised. Why is there a radar site in the middle of the Pacific? Because of shipping, presumably. Alrighty. There's also a tiny little island there. AWIS. US radar, Australia. It's not Australia. I think I could quickly find that radar site. Nope, it's not it. That radar site, if you want to find it, you need to look at satellite, not a terrain map. Okay. It's pretty obvious it would be somewhere in the Great Barrier Reef, one of these many islands. So where would this be? About 315 miles or 600 kilometers off the coast. So this would be in Cairns, basically. Okay. So this would make it be somewhere in this area here. So yes, definitely one on those islands. Found it. That was an easy find. Okay. It's not that area. It's definitely not that island. So where would it be? So Cairns. It's east of Cairns, right? Could it be that island? No, can't be. Just could be this area, but bingo. I think I found it. I think. I'm gonna confirm. Okay, let's look back at the fault. So if Cairns is bingo, 293 miles east. So it's probably this island or this one. It's probably where the radar site is. But it ain't showing up on radar, on satellite. It's not showing up on default. You gotta look at satellite. There it is. Bingo. It's your radar site. Now let's look at... I'm done with Google Maps. Now let's look at radar again. Yeah, done with Australia. Rain? I don't recall it raining this evening. In fact, it was hardly drizzling when I was outside. Now my arm's asleep for some reason because I was sitting on it awkwardly. Oh yeah, it sprinkled a little outside. Yeah, big deal. Anyway, Campo Flegrei had a few earthquakes, but nothing much to talk about. In fact, I'm going to go there right now. In fact, I haven't really been looking at Campo Flegrei. Let's look at that. Alrighty. A couple little poppers. Nothing impressive. There we go. We got one. We got two. Two little poppers in the last hour. Yep. 1, 2 poppers there. Great. Now it feels like there's ants crawling on the left side of my hand. The right side of my right hand. Ow. Yep. That's why you don't sit on your elbows. I feel like freaking ants. That's why I hate falling asleep on my hand. Alright, now let's look at the other hours. Nope. Wait a second. We got an earthquake. Yep. We got an earthquake right here. Magnitude. Alright, let's see if other stations pick it up, and yes, sir, they do. Probably a small one, probably 0.2, 0.3. That's a good size quake, probably a little shy magnitude 1. Back V does not pick it up. Yeah, it's probably under a magnitude 1. Yeah, nothing too big. All right. So you've been having a lot of small quakes, probably due to uplift, putting pressure on the faults. That's what it looks like to me, actually. Also some small background tremors. Could be harmonic, could be weather related. I mean, it is located in Macaulay. Yeah, so there's a lot of harmonic tremors that can't be flagrate, but that's likely due to gases. Not seeing a warning sign yet, but you never know at a caldera. You can get a little to no activity, and then boom, you have an eruption. Calderas don't operate on the same schedule that a stratovolcano does. Stratovolcanoes, you see earthquakes, you see the uplift, you see the harmonic tremors, boom, it erupts because there's a single conduit for the magma to follow. So it's very predictable. Stratovolcanoes are fairly predictable. Calderas, on the other hand, are very unpredictable. They do not present signs. They're gonna present every conceivable sign that they're going to erupt, like a stratovolcano. Uplift, harmonic tremors, volcanic tectonic tremors. Every conceivable sign that it's going to erupt, and it doesn't erupt. Or you could have nothing, completely baseline activity, and boom, you get an eruption. Probably from the magma that was just sitting there. Finally has enough, probably decided to go up to the surface. Probably just something, a little trigger, tiny little quake, and boom, it erupts. I'm not talking about super eruption. I'm talking about small eruption, like a phreatomagmatic eruption, more likely phreatic eruption. Campi Flegrei is definitely at a very increased risk of having a phreatic eruption, especially the Salford Tower crater. But what I'm concerned about is because of the very increased uplift that Campi Flegrei has been having over the past couple years, I'm very concerned that a very strong magmatic eruption could happen, potentially Plinian in nature, VI 4 to 6. Why am I saying 4 to 6? I haven't seen enough signs to think that a caldera-forming eruption will occur. I don't think there's going to be a large caldera-forming eruption, but there could be potentially an eruption large enough that you can get a third nested caldera within the Neapolitan yellow tuff caldera, like something like Agnano, basically. Like, it wouldn't be considered a caldera, would be considered a crater. Maybe half a kilometer in diameter, maybe as large as 2. Probably be a VI4, VI5 eruption. And that's if the uplift doesn't stop. Like, say it continues for a few more decades. Then you'll probably talk about a pretty large Plinian eruption. About VI 4 to 6. And yes, Campi Flegrei does have high silica rocks. Trachy-dacite, some rhyolite. A lot of trachy-andesite, though. Here's the thing. I haven't really found any evidence for faunolite at Campi Flegrei. But yes, I found a lot of evidence at Campi Flegrei for hydrothermally altered rhyolite and or dacite, or trachyte at least. Great. Anyway, I had a very long day. Couldn't sleep because my AC's busting. It's getting really hot at night. So yeah, I'm going to be going to bed right now. Yeah, sorry. I haven't really checked who's on my live stream. John, if you're joining me, thank you so much. Yeah, I'm watching David's live stream right now. I'm a deadly tag.
Huge.
Oh, yeah.
Absolutely big.
That's dangerous.
That is big.
Oh, my God. That's dangerously large hail. Let me look at that right now. Oh, my Lord. That's huge hail. Keep in mind that as the storm goes further and further away from the radar site, hail signal will tend to get bigger. radar beam goes higher up. Tennis ball size hail. Okay. So sun's gone down, but yes. Hail spike has been increasing. You can actually see the hail spike right here. Man, look at that hail spike. Thinking of some pretty large hail. I mean, there's definitely been a spike in activity. Not going to say there hasn't been. Wow. Wow. Wow, 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 wow. Okay, yeah, that is huge hail. I mean, that's probably going to be baseball size right there. Okay, let's go up to level 4 reflectivity. Jesus Christ. That's going to be some large hail. Holy crap, that's going to be large. Jeez. Jesus Christ, that's going to be some large hail. Okay. Bingo. Let's get up to level 4. And how high is that? That'd be 40,000 feet. And no, 50. Yeah, that's some giant hail. That is giant hail. Wow. Ginormous hail. That's definitely gorilla hail. Huh. That's an echo top right there. Let's see how high that's going up. At least according to that radar. Jeez. 64,000 feet. Holy crap. We're getting echo tops of 64,000 feet. I'm not even looking at the radar. I'm just looking at the echo tops. Echo tops. Echo. Echo tops near 64,000 feet. Jesus Christ.
Big hail beam.
Yeah, that's 64,000 feet. Oh, look at that look at that VIL. Look at all that vertically integrated liquid. That is a lot of hail.
That is impressive. Thank you for subscribing, Dustin Alexander. Still hanging in at 5 inches. 5 inches.
5 inches? I think Dave is right.
Oh, yes.
Of course, there's going to be some melting, so he's... See that right there? Bingo. Look at those echo tops. Yeah, those are 64,000 foot tops. Not even making that up. Look at that, 63,000. Those are over 63,000 foot tops right there. Those are... Yep. Echo tops over 64,000 feet. Bingo, right there. Look at that. Looks like another cell's been forming. Ah. Okay, I don't know what happened there then, but yeah. That is some really insane activity. Holy crap. Holy crap. Yep. Probably just had some softballs coming down. You're probably going to have softballs. Yeah, no doubt. No doubt, you probably just had softballs coming down. Bingo! Look at that. Holy crap. Jeez, no. Bleeding that. Jesus freaking Christ. Yeah. This is definitely the... No, this is definitely gorilla. Gorilla hail. No, gargantuan hail. This is definitely gargantuan hail. I wouldn't call it gorilla hail. This is gargantuan hail. Like, this is giant hail. Like, that's is probably like softballs. I wouldn't say grapefruit, but it's getting close. Getting close to grapefruit size, probably. Yeah. Remember when Laura Green made that false tornado warning? Saying, oh, tornado emergency. Made a tornado emergency get issued for parts of Kentucky. Yeah. She caused a tornado emergency to be issued for like if it was near the Fayetteville area. It was, where was it? No, it wasn't that area of Oklahoma. It was somewhere along the highway. Yeah, Jonesboro area. That where it was. That's where that false storm spotter caused a tornado emergency to get issued. Needless one too. You're only supposed to get a tornado emergency when you actually have a tornado on the ground, like large tornado. So and she caused a needless tornado emergency to be issued when the only threat was giant hail. Never was a tornado on the ground.
You're under
there was a lowering, but it was never a tornado.
Tomorrow. In fact, you could get some very strong thunderstorms. Potentially.
There never really was a tornado. And yeah, my computer's acting up right now. All right. I'm going to go to the Weather Hub right now. Oh, I got one person watching, which yep, softballs. Yeah, hey Johnny. Man. Yeah, we got softballs probably. Hey, Johnny, I'm good. Again, I'm really sorry about what happened. Let me see. Okay, I'm going to stop watching it. I'm going to go to Stream Analytics. Just want to make sure I'm not watching my own stream by accident. Yeah, let's go to live. Okay, I'm just gonna click here. No save. Okay. Stream Analytics. It says I have a viewer. Let's see when that comment was made. Looks like it was probably made in the last few minutes. Hey, Johnny. Okay, because I clearly exited my own stream. It still says I have a viewer. Hey, it means that Johnny's here. Hey, Johnny. Oh, great. Just testing a lag right now. Okay, the lag isn't bad, about 10 seconds. Yep, the hails are definitely, they're not soft, they're huge. Talking about softball as in like the type of baseball, it's larger than baseball. Yeah, softball-sized hail. I wish they were soft, but nope. Oh, great, new cells forming now. Hopefully that'll be it, but yeah, storms are hailing themselves out right now. 64,000 foot tops. Holy crap. Yeah, I kind of did miss the joke. Yes, the balls and the hail are yeah, jokes kind of go over my head sometimes. Just really tired right now. I couldn't sleep at all last night because my AC broke. I'm running on fumes right now. Anyway, we got potentially more hail tomorrow. Actually, part of eastern Oklahoma is actually an enhanced risk for hail. There's actually there's an area in Texas and Oklahoma that is not in the wind or the tornado, but has an enhanced risk for hail, 30% enhanced risk for hail, like a large part of West Texas was today. Yeah. Crazy, right? And now some of the models are forecasting wet snow for the Northeast. Just wow. Like, can Mother Nature get any more crazy already? Yes, this is because of global warming, but still, this is crazy. This is like so crazy. I mean, look at this. Oh, sorry. Wrong model. 12Z now. 12Z, not 6Z. Damn finger. Come on. There we go. Bingo. And that is not looking good for snow. Yeah, it's showing cold air, but how much of it is going to be actually making it down to the surface? That's the big question. Okay, maybe some... Yeah. A little bummed out. Anyway, Camp Flegrei is not acting that bad right now. Yeah, there's some earthquakes, but nothing too crazy. Some ones. Nope, nothing too crazy. Depths. The deeper depths are caused by magma. The shallow depths are hydrothermal. Anyway, I'm going to bed in about 5 minutes. Let's look at the SPC. Oops. I want to look at the outlook. Day 2. Looks like areas north of Oklahoma City going to be kind of in danger. And then day 4. Up. Oh, wow. Already another one? Day 4 and 5. I want to chase on day 4. Man. Guess I'll have to wait till next year's severe season. Okay. Yeah, this week is definitely going to be busy. This is about when Oklahoma gets it really bad. I'm really worried about day 4. Or should I say day 3 now? They're about to change that day 4 to day 3. That's already enhanced. I wouldn't be surprised if a moderate gets issued for day 3. That's going to be Thursday. Thursday is going to be a really big day for Oklahoma. So Monday's day 1. Actually, Wednesday. I'm really worried about Wednesday now. Yeah, Wednesday is going to be for Oklahoma. Thursday is going to be for Arkansas. Parts of northern tip of Louisiana and eastern Oklahoma, eastern Texas. There we go. There actually may be an enhanced that's going to be issued. That happens to be right where my friend happens to live. Damn it! My friend lives in Ada, Kanawha area, basically. That's a little concerning. Actually, it's quite concerning. Going to Oklahoma City area for tomorrow. Let's see. Probably after about 0Z, you're going to have severe weather, right? Nope. Let's see. 0Z. Bingo. So you're going to have a squalling, basically. Wow. That is impressive. Holy crap. Yeah, you see that? That is a lot of hail. That's also very high helicity. Let's look at updraft helicity swaths. Bingo. Wow. So they're saying that a long track tornado may occur on the northern Kansas-Oklahoma border. Northern Oklahoma, southern Kansas border. There could be a tornado. Wow. That's not good. Significant tornado parameters or super... Yikes. That's not good. That is very not good. Yeah, that's some really, really high SIGTOR parameters for tomorrow. Wow. That's not good at all. Okay, let's look at the NAM Nest. High resolution NAM for tomorrow. Holy crap. Saying single cells, but if any discrete storms develop, oh my god, they're going to be tornadic. Wow. Wow. Wow, 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 wow. Yeah, I'm worried. Oklahoma City may get some really violent tornadoes tomorrow. Holy crap. Shoot. That looks even worse than today. Yeah, now I'm looking at last night's run for today. Didn't look too bad. Yeah, but when you look at that, she may even issue a moderate for tomorrow. Holy crap. Yeah, that looks like a moderate. That's definitely a moderate going to be issued for tomorrow. Draft helicity swaths. Bingo. Boom. Look at that, right just west of Oklahoma City. Look at those high values. Fuck. Shit. Now let's look at the temps. I said temps, not... Okay. Alrighty. That is a big time hailstorm. And a tornado outbreak too. There we go. Oh, got 2 people joining. Well, thanks for joining me. Looking at Oklahoma right now. There we go. That's what I was looking for. Big hail spikes. You see that right here? So it hailed. Boom. Right there. See that area of cold temperatures? That's the HRRR forecasting hail. Yeah, that's hail. See that area of cold temperatures? Right there, that's hail. Yep. Boom. Hail. Wow, it's going to be chilly in Oklahoma on Tuesday, but yeah. Yep. So that's going to be some either giant or a lot of hail that's going to come down. It's probably more like the amount of hail that's going to come down. Yeah, when you see gray, that is crazy hail. Those updraft helicity swaths ain't playing around. Yeah. Precipitation type, of course, it's going to show rain. Can't really tell the difference between rain and hail because it's severe weather. Plus, you're going to be near the 5700 line. But yes, it can tell hail. That's why I'm looking at simulated reflectivity. Boom. That's hail. That's a giant hailstorm. Let's look at wind gusts. Bingo. Look at that. Right there about... You can almost see the supercell, actually. It is literally showing the supercell. Ain't that crazy? Right along the cold front, the HRRR is forecasting a freaking supercell. Oh my God. Holy crap. Yeah. The HRRR is forecasting a supercell. Just wow. Make sure my microphone's on. Okay, microphone's on. Good. Just want to make sure everyone can hear me. Alrighty. Ooh, wow. Outflow. Yep, that's the storm gussing themselves out. And that here is a supercell. I mean, this is only one model, but yeah, showing a supercell. What am I really concerned about is actually that area, northern Oklahoma. That's about where I'm concerned. North of Tulsa, that's about the area I'm really concerned about too, so yeah. Makes sense. However, NAM is saying something else. I would go with the NAM more right now, but let's wait for the 6C NAM to come out. Ow. Alright. day I'm really worried about is Wednesday. All eyes on Wednesday. We may have a pretty bad tornado outbreak. Hopefully it won't be as bad as May 3rd or I'm just hoping it's not going to be as bad as May 3rd or May 20th. Hopefully it's not going to be as bad as the 3rd or the 20th, but yeah. There's a chance we may get a couple long-track violent tornadoes. All right, I'm going to bed right now. Didn't get any sleep, so I'm just going to be very careful tomorrow in northern Oklahoma. This is the area I'm most concerned about. I'm actually going to highlight it on Google Maps. Area I'm most concerned about. Let me go to default. Okay. Very concerned about areas Oklahoma City northward. So, Tonkawa, Ponca City, Osage Reservation, Bartlesville, Tulsa. But I'm more concerned about north central Oklahoma. Not northeastern so much, but north central. So, Enid, Stillwater. Areas west of Tulsa, north Oklahoma City, be on the lookout. Also, areas west of Oklahoma City should be on the lookout too. But I'm also concerned about Oklahoma City itself. So yeah, I have a friend of mine who lives in the Seminole area. Anyway, Ada. That's what I'm really worried about for Wednesday. Especially South Oklahoma. Far north Texas and south central Oklahoma. I'm really concerned. Anyway, with climate change getting more and more prevalent, with climate change having more an effect on our weather, getting more severe weather outbreaks, you're getting more severe droughts, more severe floods. Basically, everything that's the extremes are becoming more extreme. It's not because weather reporting is getting better. It's because the extremes are getting worse because climate change is getting worse. Should I say global warming is getting worse? We like saying climate change, but climate change means natural climate. What is going on now is not natural in any way, shape, or form. Here's the thing. Mother Nature emits more carbon than we do, which is true. My climate professor said that. But the thing is, no one has taken into account. Mother Nature did not account for us to start dumping. We are that extra factor that Mother Nature never planned for. Have you ever heard of the Siberian Traps eruption, the Permian mass extinction, the Great Dying? That was a volcanic eruption, a flood basalt eruption, one of the rarest forms of volcanism. Happens only once every several 100 million years, or once every few tens of millions of years. Usually formed by a new hotspot that comes up from the mantle. Actually, they imagine the 1783 to 1784 Laki eruption, but every year for centuries and millennia. Every year. Yes, the Siberian Traps eruption emitted the amount of carbon that we're emitting every single year for several thousand years. CO2 levels became so high that oceans acidified. You had mass asphyxia in the ocean. Over 95% of all ocean species went extinct. Over 75% of all land species went extinct. The land extinction was caused by a combination of the food cycle collapsing and also climate change. The Arctic region became tropical. You had tropical plants growing in the Arctic. Sea level was several hundred meters higher than what it is right now. There was no Antarctic ice sheet because A, there was no Antarctica there, and B, all ice caps, all sea ice disappeared. The whole planet was basically being cooked alive. to cause a giant volcanic eruption that just never ended. It wasn't explosive, it was effusive. It was a flood basalt. This is what we're doing to our planet. We've only been doing this for, 80 years? But the thing is, every year the Siberian Traps eruption never emitted the amount of CO2 that we're emitting right now. That's the thing. We may manage to do this in only a couple hundred years, what the Siberian Traps eruption managed to do in several 100,000 years. Just putting that out there. Also, while nature frequently has volcanic eruptions, it doesn't always erupt. Thing is, also Mother Nature takes back the carbon what the Earth puts out, it puts back in. But the thing is, we're cutting down trees, we are consuming more carbon, we are releasing more carbon, we're consuming fossil fuels and releasing more carbon, but we're not removing the carbon that we are putting out there. So we are that extra factor that the cycle never really planned for. Everything was in balance until we showed up. Or, 250 million years ago, everything was in balance until a massive flood basalt eruption occurred. That was natural. But we are not natural. What we are doing is not natural. This is not even our genetics. This is not our bodies. This is our activity. Our activity, just the desire to build stuff. Of course, first life forms did cause a mass extinction event, but that was just their existence. Like how you have chlorophyll converting carbon into oxygen just to stay alive. And then using oxygen, releasing oxygen as a byproduct. That actually caused the first mass extinction. But that was natural. Again, it wasn't like they were doing it to thrive. They weren't doing it just so they could, have fun, build stuff. No. That was their process. Like how we breathe out carbon. We contribute carbon by breathing it, and we're releasing more of it. I'm not saying we should stop breathing. We should stop burning carbon. Instead, use coal to make batteries. How? Very easy. Coal is made of carbon. And what happens when you make single strands of hexagonal carbon atoms? You get a wonder material called graphene, which you could use to make batteries for electric cars that are 60 times better than lithium-ion batteries. Ergo, recyclable, charges and discharges much better, and can actually be used for battery storage. So instead of using coal to cause climate change, how about we use it by not burning it to actually stop climate change, to halt what we're doing? And you don't have to constantly mine coal endlessly, because here's the thing. You're actually using it in batteries, and means it's reusable. So you're actually, coal is, we'll never run out of it. We won't have to mine as much as we do now. Just one truckload of coal will probably produce enough batteries and graphene to last to, I don't know how much, I don't even know. That's probably what the scientists would know, but it's going to be on the order of 100 times less pollution, maybe even several thousand times less. But yes. Anyway, I'm going to bed right now. Just wanted to leave you off with some of my thoughts on what we should do to better conserve our planet. Not just our way of life. I think we should focus more on the healing of the planet than our way of life, in my opinion. We should still not live in poverty. No one should be living, outside in the cold. But we should, it's also good if we can progress ourselves and also help nature. But unfortunately, that's a lot of greedy people don't do that. They decide to be very wasteful. Okay, let's get rid of nuclear waste by burying it, instead of building better reactors that can actually consume the nuclear waste as fuel. It's pretty obvious that the liquid fluoride thorium reactor will do that. But instead, cutting down trees for fossil fuels, transporting nuclear waste to waste storage facilities, when when nuclear waste shouldn't be stored. It shouldn't even be waste. It's literally unspent fuel. Well, yeah, I'm going to bed. Good night, everyone. Thank you.